For my video explanation, I chose to do power series, so here we have a power series. It is x to the power of n over n times 2 to the power of n. Basically what we want to find here is the interval of convergence. This is an interval of x values that tell us whenever x is within this range of values, the power series here is going to be convergent. So what we want to do is find convergence. So one way we can do that is by taking the ratio test. The ratio test is a test that requires a little bit of knowledge about limits. Good thing we know. Basically it tells us whenever we take the limit as n approaches infinity of the series here with all the n values plus 1 over the original series, which is what I have set up right here. Whenever that solution is known as L, is less than 1, the series here is convergent. So what we want to do is solve this here, this big mess. So what we can do is move the numerator of the fraction down here into the denominator, and this one down here into the numerator, and that's what we have right over here. It's going to be x to the power of n plus 1 times n times 2n to the power of n times n plus 1 times 2 to the power of n plus 1 times x to the power of n. To simplify this further, we know that we can take that x to the power of n and x to the power of n plus 1. We learned this year that because this is a limit as n approaches infinity, no matter how big n gets, because it's n plus 1, there will always be one more x in the numerator, meaning we can cancel those, and we get left with just an x up there. Similar case with the 2 to the power of n plus 1 to the power of n. Goodbye, and we're left with just a 2. So we've got that 2, that n plus 1 in the denominator, that x, and that n left in the numerator, which is what I have set up right down here. And then it's also, limit as n approaches infinity. We can distribute the 2, just take some algebra, x times n over 2n plus 2. Then we want to get rid of all these n's. So one way we can do that is by dividing all the values here by n. X times n over n just cancels out the n's. Same thing with that 2n. Cancel out the n's. And then what we're left with is x over 2 plus 2 over n. And that 2 over n is kind of special because it's a limit again as n approaches infinity. That 2 over, it's pretty much 2 over infinity, which is just an infinitely big number, which means because it's 2 divided by an infinitely big number, it's going to be infinitely small, so small we can just pretty much count it out as 0. So we'll cancel that out. And that step requires some previous knowledge about limits. And then we're just left over with that x and that 2, which means we have our solution to this limit. The limit as n approaches infinity is equal to x over 2. And then we remember that whenever L, the solution, is less than 1, the series is convergent. So what we can do is set the absolute value of that to less than 1. Solve for x, multiply both sides by 2, and get that x is less than 2 is our final solution. With that, we can just think for half a second and get negative 2 to 2 is the interval that x is allowed to be and still be less than 2. And that is the interval of convergence that tells us that, yep, x can be within these values here, and this series will be convergent. Our radius of convergence is 2. Also cool to know. That's about it. Just one more time real quick. We have a power series here. We want the interval of convergence. To do that, we can take the ratio test. Whenever the solution to the ratio test is less than 1, it means that this series here is convergent. So we solve using some algebra, some limit knowledge, and we get x is over 2 as our solution to that limit. We set that to less than 1 because of that L. Solve for x and get our solution as negative 2 to positive 2. That's about it. Thank you very much.